Assalamualaikum warahmatullahi wabarakatuh. So today, my friends Muhammad Azim bin Muhammad Adanan and I, Umi Dabla binti Syukur, will present our mini project titled IP/ICMP attack. So this is the introduction to IP or ICMP attack. It is actually a type of cyber attack with the attacker aim is to launch an assault by the cyber criminal to their victims, and it is categorized as a DOS attack, which is denial of service attack, where the attackers normally interrupt the device or machine normal behavior via single computer only. So what is the objective? Our objective for this project is to gain the first-hand experience regarding on the various attacks that occur at the IP layer using SID Ubuntu VM via Oracle VM VirtualBox software. So now I will pass to my friend Muhammad Azim to continue the methodology and result for part 1 for task 1. Thank you.
Okay, thank you, Nabila. Okay, now I want to start explain the methodology and result. First one is task one is IP fragmentation. Okay. IP fragmentation is an Internet protocol process that breaks packet into small. The following code is used to construct the UDP packet and send it to UDP server. Okay, in this task, machine A, we using two machine, two VM. One is machine A and machine B. Okay, machine A will send an IP packet which is divided by 3 fragments. So which means there is 3 fragments we will divide in one packet to send to machine B. Cool. So this is the code. So from the lab sheet, we just change the destination. This is the IP address to destination machine B. This is the source, which is the internet, and we change the payload, which is the packet that how many packet we want to send to the server. So in the task we need to specific. We already specify where the first packet the 3 packet. The 3 we need to have 32 bytes data. So we justify here A32, B32, C32, and the total is 96 actually. Just ignore this comment. Okay. Then we need to check the Wireshark in the another virtual machine. So as we can see, this is the total data that we need to receive, which is 96 bytes total of data. So the task is successful. Then this is what it means just now. A, we have A32, B32, and C32. All this is assemble. We assemble back. Okay, next for the task 1B, IP fragment with overlapping content. Okay, the following code is used to construct 3 fragments and send to the UDP server. But first and 2 fragments should overlap. In this task, we need to construct 3 fragments to send to UDP packet. Where the first and the second fragment should be overlapped. So in order to do that, the value of first fragment should be the same as the offset. So that's why this is here is 800, same as 800. So in this task, there are rules you need to follow, which is the value k, the first data, and the offset of the second data should be the same, and also the second fragment should be smaller than the first fragment. So we follow the rules. So at here we define our payload, which is the first fragment is 100, second fragment is 600, and the last fragment is 500. They will be sent to the UDP server. So next we need to check the Wireshark from the receiver host virtual machine. So you can see here we only receive two fragments, which is the first fragment and the third fragment. Sorry if you can't see it, but this is the third fragment. The second fragment is overlapped with the first fragment, so we cannot see it. This IP fragment with overlapping content are called a teardrop attack, which is one of the denial of service attack. The packet overlap one another, crashing the target network. So this is type of DOS attack, which is called a teardrop attack. Next, 1C is sending a super large packet. So this is the code is used to construct a super large IP packet to send to UDP server. This is the code used here, which is ping.s dash s. This is the value of how many packet we want to send to the victim. This is the IP address of the victim. This is the attacker view in the command. So after we run, there will be continuous ping packet sent to the destination, to victim. It will be continuously until we stop it manually. Then the victim view. This is the before receiving the packet. You can see here, nothing, and also the network is still stable after receiving. Here you can see there's so many fragment packet received, and also there is the high peak change at the network, making the system very lag. This attack is also one of the DOS attack called ping off death. The data sent from the attacker are larger than the server cannot handle. The data package are larger than what the server can handle. So this will affect the server to be freeze, reboot, or crash. Next is sending incomplete IP packet. In this task, machine A will send a lot of incomplete IP packet. In this task, we will be using hping. You need to download it first. Hping 3 is open source. Is available in open source, where the code is hping, right? So the dash c 15,000 is the packet we want to send. The D means the size of each packet is 120 bytes. The dash ends means we need to specifying that the SYN flag should be enabled with TCP window size of 64 dash W. Here, dash W 64 is the TCP window size of 64 to direct attack the victim web server. Just specify port 80 here, port 80, and use the flood flag to send the packet as fast as possible. The last the this dash dash ran dash s source flag generate spoof IP address to the destination. Okay. Destination to attack, which is the IP address. Result, we after we run this, we can see the result in the another VM. This is the result. There's so many. You can see here the red line. This is the what I mean the TCP detect incomplete IP packet. This attack saturates its resource while the server is waiting for the end of the request. So this is the same policy adopted by SYN flood attack. One of the DOS attack where the three-way handshake is not complete. It's similar with the SYN flood. That's why I use this command. But in this case, the attack is launched at the application layer instead of transport layer. Okay. Okay, next task 2 I will pass to Nabila to explain.
Thank you, Azim. So now I will explain for task 2 ICMP redirect attack. ICMP is stand for Internet Control Message Protocol. So what is ICMP redirect attack? ICMP redirect attacks occurs when the attacker modified the routing table of the victim. So we can see in the figure, this is the victim, and when the attacker modified the routing table of the victim, the router will inform the victim there is more efficient route to a destination. So here the destination is this target server. So once the router inform that there is more efficient route to a destination, the victim will believe and it will adjust the routing table. For example, where the victim client wanted to send packet to the target server, where the target server is in different LAN network between the victim and the target server, so you need to pass through the router. So once the packet is here at the router, the attacker, which is the Kali, will launch the attack, and it will send the redirect message and causing the routing table to change. And ICMP redirect attack, also known as M.10 attack, which is man in the middle attack. So this is the Python file used to launch the attack. This Python file is written in the attacker VM machine, and here at the ICMP for function, the type is equal to to type is equal to 5, which means redirect mode for the ICMP attack, and code is equal to 1, means redirect datagram for the host. So here ICMP.gw, it describe the attacker IP address or the machine IP address where the attack is launched, and here is the route of the packet from the victim as the source and to the destination, the target server. And this is the result shown in the Wireshark after the attack is launched. The Wireshark software supposed to be checked or open in the victim VM machine. So once we open the Wireshark, we could see uh, a packet sent from the gateway address or router to the victim, where the packet info is redirects. So meaning that our attack is successfully launched. Besides that, we also can verify our attack, the attack that has been launched using terminal, by using IP get function. So once we use the IP get, this is the real destination. So the output will pop up like this, which means this is our destination. We are 10.021. This is our gateway address. Des Empus source 10.0.2.11. This is our attacker or our attacker IP address. So this means that our a packet has been redirected. With that, I pass to Muhammad Azim to explain about task string routing and reverse path filtering.
Thank you, Nabila. Next, I will continue explaining the task tree, which is routing and reverse path filtering. Okay, for the first task, network setup. So we need to set up 2 network and 3 VMs, which is I name it Mission A, Mission B, and Mission R. Mission R is we assign it as a router. So in this task, we need to Mission A and Mission B, Mission A and Mission R will have a same network. We will be using NAT network, and Mission B and Mission R will be attached with internal network. So that means Mission R, the router, will have a 2 network at him. So because of Mission A and Mission B have a different network, so Mission A cannot communicate with Mission B. So in this, okay, but Mission A can communicate with Mission R because they have a same network. In the 3.B, okay, sorry. We need to configure the routing on Mission A, B, and R so that A and B can communicate. Previously, Mission A and Mission B cannot communicate because they have a different network, right? Using the routing table, can create the routing table on these 3 machines so that Mission A can communicate with Mission B or vice versa. So to do that, first we can display the current routing table using IP route. If we run this, we can see they will display the routing table. If we want to add a routing table, we just simply sudo IP route add. add. This is the network, destination network. This is the device internet used via. This is the IP address of the hopper. What I mean is, okay, just now, this one, right? Okay, this is a routing table for machine B. So this machine B here. We need to communicate with machine A. In order to do that, we need to create the routing table so that the system can make a path to him to communicate. So in order to do that, we use the sudo IP route add to the destination network, which is 10.0.20, sorry, 0/24. This is the machine A network. This is the IP address. So I should put, forgot to put the network here, sorry. Device ENP0S3 using the ENP03, that's why I add here, via hopper at IP address of the router hopper. What I mean is the hopper is which router that we use in the on the way of the path to communicate with machine A. So machine B will happen to go here first before arrive at machine A. That's why we need to via machine R IP address here. But machine R have a two network. Why I pick this address? Because it happened there both have the same network at this IP address. This one is same with this. That's why I choose it. For machine A, we can choose this as the IP hopper address to communicate to machine B if we want to create routing table at machine A. So in this example, I just show you machine B routing table. Just same as machine A and machine R, just do like this, IP route 8. Then we display back the IP route. Here we see that the IP route we create just now is saved at here. It's at the second line. Okay, next. In order to communicate machine A and machine B, we need to configure R as a router. In order to do that, machine R need to forward packet so that it can be function as gateway. Using this command, just copy and paste at machine R terminal. After we can run it. So now we can ping machine A and machine B. So this is the result. This is machine A view where we ping this the machine B IP address. So it show that it's successful to ping and also successful to telnet. Same as machine B. This is machine B view. We ping machine A IP address, also successful. Next, 3.C is the reverse path filtering. In this task, we need to send 3 spoof packets on machine A. All these packets should be sent to machine B using the source IP address belonging to the network. Next will be Wireshark will be run on both machine B and machine R to check whether the spoof packet are forwarded to the internet network or not by machine R. What I mean here, machine A already sent the spoof packet. So remember the routing table. Machine A will send spoof packet to machine B, but in order to do that, need to it will be forward to machine R first. So that's why, in order to machine B to receive it, that's what it means. Okay. This is the command to verify the IPv for reverse path filtering. If you see it equal, if this line is unavailable, you might add it to the line. It just equal to 1. Is also, if this line is equal to 0, just edit the line to make it 1 to in order to RP filtering is available. Okay, this is start to send the spoof packet to the destination address. So this is the command where sudo iptable ni csnet adalah to the source. This is our network we choose here. No need to put the subnet. Okay, then we start ping at machine B address. So you can see here 5 packet transmitted 5 times, and we will see the Y shark from this one is the machine R Y shark. You can see that the machine R detect those 5 packets sent by machine A. Here ICMP safety protocol here 5 times. You see there 5. But is it forward to machine B? Okay, we find out. Okay, so machine B doesn't receive any packet, so that means the machine R doesn't forward those 5 packets. This is the view machine R. Machine R have 2 network just now. So this one is the result of the first network, NAT network, and this one is the result for the second network, which is the internal network. Yes, so I want to highlight that sorry based on the result above, you can see that the spoof packet isn't forwarded by machine R to machine B. We can see the packet from the incoming interface, while the other interface also didn't receive packet, right? This is because the reverse path filtering protect against the spoof source address by causing the system to discard packet with source address that have no route or a route that does not point forward to the originating interface. So that means the reverse path filtering is good for it's a good thing. Yeah. Okay, that's all from us. Thank you.